Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. We continue with our topic of discussion. The topic is chlorine and its compounds, and we are looking at the chemical properties, and specifically we are looking at how chlorine reacts with alkalis. So the reaction of chlorine with alkaline solutions. So first of all, we said that chlorine is an acidic gas. So being an acidic gas, it has the ability to react with alkaline solutions. Solutions such as sodium hydroxide, potassium hydroxide, calcium hydroxide, and so on and so forth. So in this case, we have different types of salts that are formed by chlorine gas. Remember, chlorine forms two acids. There is the hydrochloric acid and there is hypochlorous acid. So from hydrochloric acid, we form salts that are called chlorides. And then from hypochlorous acid, we form salts that are called chlorides. So in this case, I will say that when chlorine reacts with cold and dilute sodium hydroxide. So when chlorine reacts with cold and dilute sodium hydroxide, we form two salts. We'll form sodium chloride because of the presence of hydrochloric acid in chlorine, and we shall also form sodium hypochlorite. So sodium chloride, sodium hypochlorite, and water are formed. So we are forming two salts. So we have chlorine plus sodium hydroxide, cold and dilute. So temperature is very, very important, and also the concentration in this particular reaction. So in this, we'll get sodium chloride. We'll also get sodium hypochlorite plus water. So this is a neutralization reaction whereby when chlorine gas dissolves in water, we form hydrochloric acid and hypochlorous acid. Hydrochloric acid forms chlorides. Hypochlorous acid forms chlorides. And then there is water being formed. So to check the balancing, chlorine, we need to balance the sodium, 1, 2, oxygen, 1, 2, 1, 2, hydrogen, there are 2, and chlorine, there are 2. So that equation is balanced. Now, on the other hand, if chlorine reacts with sodium hydroxide, that is hot and concentrated, we shall not form sodium hypochlorite. We shall form sodium chlorate. So sodium chlorate has a higher oxidation number compared to sodium hypochlorite. And that is as a result of the high temperature and the high concentration. So we have chlorine plus sodium hydroxide, and this one is hot and concentrated. So the temperature is very important here, and also the concentration. So we'll get sodium chloride, just like in the previous case. But here we shall form sodium chlorate as the salt with a higher oxidation level, or with a higher amount of oxygen plus water. So we'll have sodium chloride, sodium chlorate, and water. Here we had sodium chloride and sodium hypochlorite. Can indicate here that this is sodium hypochlorite. That is when we use cold and dilute sodium hydroxide. When we use hot and concentrated sodium hydroxide, we get sodium chlorate 5. So we are saying that in this case, chlorine forms sodium chlorate 5 and sodium chloride. And then, of course, we have water. So if, for example, we can also take another example when potassium hydroxide is used the same reaction occurs as shown above. So we can say that if we have chlorine plus potassium hydroxide, this is cold and dilute, then we'll have potassium chloride, potassium hypochlorite plus water. And then on the same, if potassium hydroxide is hot and concentrated, then we'll have potassium chloride, potassium chlorate plus water. So potassium hydroxide behaves the same way as sodium hydroxide. So when it is hot and concentrated, we form sodium chlorate 5 or potassium chlorate 5. When it is cold and dilute, we form sodium hypochlorite or potassium hypochlorite. So we'll have an assignment on that. So the assignment, name 2 factors that affect the reaction of chlorine with alkalis. We have mentioned those factors. Number 2, write a balanced chemical equation for the reaction between chlorine and hot and concentrated sodium hydroxide. So basically is to balance this particular equation. So we'll stop there. Until next time, goodbye.